Hello everyone. Today I am going to discuss electromagnetic waves, laws of reflection and refraction of light, total internal reflection, image formation by mirrors and lenses. Let's start with electromagnetic wave. What is light? What is the speed of light waves? So what is the relation between light and electromagnetic wave? So light is basically the electromagnetic waves that can be detected by human eye, and in case of electromagnetic wave, the variation of the electric field and magnetic field produce a wave which is called electromagnetic wave. And the speed of light quanta, which is basically phonon, the quanta of light is called phonon, is c equal to 3 into 10 to the power 8 meter per second. And if you consider in three-dimensional case xyz direction, the propagation of the wave is considered along the direction of x, and due to the variation of electric field and magnetic field along the y direction and magnetic field along the z direction, then due to the variation of this electric field and magnetic field, there is a wave produced in this case. So the produced wave propagate along the x-axis, and this wave is called electromagnetic wave. And the velocity of the electromagnetic wave is 3 into 10 to the power 8 meter per second. It may vary due to the medium of the transmission. Okay, why the sky is blue and why is the sun red at sunset? Now we know that basically in color of the particular things, the variation of the wavelength started from the blue color is shorter wavelength, started from the shorter wavelength which is blue, and ended the longer wavelength which is red. Now when basically in mid day, shorter wavelengths are scattered from the direct beam from the sun at the midday more effectively than longer wavelengths. So that's why the scattered waves produce the blue sky. And at sunset, light from the sun travels further through the atmosphere than at midday. The shorter wavelengths are scattered out of the beam, leaving the longer red wavelengths. So that's why the sun is red. Now, how can we define wavefronts and rays? Figure shows there is a wave produced in water, and propagation direction is also shown. And a wavefront is a set of points of equal phase. Each of the circular wave crest in figure can be considered a wavefront. So here basically figure shows different wavefronts here, and a ray is a point in the direction of propagation of a wave and is perpendicular to the wavefronts. So wavefronts are basically particularly a point, okay, or particular radial part, or particularly a, a plane mainly. For a circular wave, the rays are ready pointing outward from the point of origin of the wave. This is basically figure A. For a linear wave, the rays are a set of lines parallel to each other, perpendicular to the wavefronts. So here in second case, straight lines are represent the wavefronts, and ray are represent perpendicular to this wavefront. And in first one, basically circular lines are represent the wavefronts, and perpendicular points away from the origin of the source represent the ray. So here is also a similar thing, basically spherical wavefronts and planar wavefronts. Now let's talk about the Huygens principle. So Huygens principle mainly describe the produce of the new wavefront. So if particularly rays basically rays disturbed from particular point, then the new points describe the new wavefront. Okay, so at some time t, consider every point on a wavefront as a source of a new spherical wave. The wavelets move outward at the same speed as the original wave. At a later time t plus del t, each wavelet has a radius b del t. So this is basically s equal to vt, where v is the speed of propagation of the wave. A figure shows the same thing. So basically, wavefront, here is the wavefront, and there is a new wavefront produced here. So each of the particularly wavefront describe the new wavefront produce of the new wavefront. So each of the wavefront are the source of the new wavefront. Okay. Now the reflection of light. So if we consider the rays incident on a surface, then it come back to the same surface or same medium, then this is called basically reflection of light. So due to the density change in density of the medium, there will be intensity of the light will increase decrease. Basically, the laws of reflection summarize the relationship between the directions of incident and the reflected rays. So if we consider there is a medium or there is a particular obstacle, from that there will be a particularly reflection occur. The laws are formulated in terms of the angles between a ray and a normal, a line perpendicular to the surface where the ray touches the surface. Now let's see the particularly figure related to this thing. So here is a particularly glass, which is the obstacle of the ray. So incident ray, this incident ray is incident on the surface, basically on the glass, then reflected from that surface. And if we draw a perpendicular line to the incident ray and particular reflected ray joined in a point, then if we draw a perpendicular line which is called normal to the surface, then the angle produced by incident ray and the normal is called incident angle, and the angle produced by reflected ray and the normal is called the reflected angle. So incident angle is represented by theta I and reflected angle is represented by theta r. Now the laws of reflection, the angle of incidence equals the angle of reflection. So initially theta I is equal to theta r, and the reflected ray lies in the same plane as the incident ray and the normal to the surface at the point of incident. The two rays are on opposite sides of the normal. So here is the same thing, particularly the point is normal and incident ray and reflected ray are joined in the same point, and the angles are in opposite side of the normal. Okay, but in same medium. Okay, then specular and diffuse reflection. If the surface is smooth, then the reflection occur is called particularly specular reflection, and if the surface is particular irregular shape, raw surface, then the particularly reflection is called diffuse reflection. And basically in our daily life, diffuse reflection is the example, and diffuse reflection is more common in everyday life. Okay, and the refraction of light. Okay, so reflection, the changing of direction of a light ray as it passes from one medium into another medium. So if we consider the two medium, one is air, another is glass, then some light will basically incident, if some light incident on the air to glass, then there will be particularly come back to the same medium, some part of the light come back to the same medium in air. This is called refraction. Okay, reflection. And if particularly pass through the glass, this is called basically refraction. So according to the Huygens principle, we can particularly understand this phenomena. So basically the thing is that the laws of reflection is reflective index is denoted by n. So if we consider the incident uh, part, the reflecting index of the incident medium is Ni and the transmitted medium is Nt, then Ni sin theta I is equal to Nt sin theta t. So the multiplication of reflecting index and sin incident angle is equal to multiplication of reflecting index in second medium sin theta t is equal basically. And the second law is the incident ray, the transmitted ray, and the normal all lie in the same plane, the plane of incident. The incident and transmitted rays are on opposite side of the normal. Snell's law. So Snell's law is basically depend on the refraction of light. So in case of refraction, we can say that n1 sin theta 1 is equal to n2 sin theta 2. So here n1 and theta 1 are the basically reflective index and incident angle in first medium, and n2 and theta 2 are the reflective index of second medium and transmitted angle respectively. Now let's solve a problem related to this topic. A beam of light strikes one face of a window and with an angle of incident of 30°. The index of refraction of the glass is 1.52. So the reflective index of the glass is 1.52. The beam travels through the glass and emerges from a parallel face on the opposite side. Ignore reflections. Find the angle of refraction for the ray inside the glass. And the thing is that here the reflective index of air is 1. And according to the Snell law, n1 sin theta 1 equal to n2 sin theta 2, then sin theta 2 equal to n1 by n2 sin theta 1, which is equal to 0.3289. And finally, the angle transmitted angle theta 2 is equal to 19°. Now let's talk about total internal reflection. So according to the Snell law, if a ray is transmitted from a slower medium into a faster medium, initially for a higher index of refraction to a lower one, the reflected ray bends away from the normal. This is shown in the figure B. Okay. In figure A, if the incident angle is 0, then some part is reflected in same direction and some part is transmitted in 0° angle mainly. Okay. Then basically the angle of refraction is greater than the angle of incident if we consider the reflective the angle of refraction is greater than the angle of incident. This is shown in figure B. As the angle of incident is increased, the angle of refraction eventually reaches 90°. So at 90°, the refracted ray is parallel to the surface. It isn't transmitted into the faster medium. It just moves along the surface. The angle of incident for which the angle of refraction is 90° is called the critical angle theta, which is denoted by theta c. So here we see that if we increase the angle of incident, then particularly there will be transmitted ray away, just go away from the normal, and at a certain incident angle there will be no transmission occur, and we find out a transmission of 90° reflected ray of 90°, and this angle is called critical angle. And according to the Snell's law, you can easily find out the critical angle. So Ni sin theta c is equal to Nt sin 90°, because the transmitted ray produce 90° angle with the normal. And if the angle of incident is greater than theta c, critical angle, there cannot be a transmitted ray. If there is no ray transmitted into the faster medium, all the light must be reflected from the boundary. This is called total internal reflection. So if we incident a ray greater than angle of incident angle than critical angle, then all the rays reflected, there will be no transmission occur. So this is called total internal reflection. And here is the example of the total internal reflection in optical fiber. Basically, principle of total internal reflection is used.